All right, honors, we're on our last set of notes talking about solubility and what that means. So what is solubility? Again, please have your note, back it out. Be willing to pause the video if you don't understand something, to take some moment to think about it, rewind it if you need to go over a concept again, talk with your instructor, talk with each other, teach each other. The best learners are those that teach. Even if you think you don't get it, go find somebody and quickly explain it to them, because you'll do a lot better. So solubility. Solubility is the ability to dissolve in a solvent. It's literally how well can something dissolve in something. That's solubility. So solubility depends on the atomic attraction between solute particles and solvent particles. Remember, solute is the actual substance you put in the solvent to be dissolved. And so depending on the atomic attraction between those particles depends on how well this thing is soluble or has the ability to dissolve. So solubility is the ability to dissolve. Remember, like things dissolve like things. What do we mean by that? Well, if you have a polar solute, excuse me, if you have a polar solute, so if you actually look at the compound and the compound is polar, if it has a dipole, then the polar solute can dissolve in a polar solvent. So water is a polar solvent, and things that are polar can dissolve in water. A nonpolar solute will dissolve in a nonpolar solvent. So like things dissolve like things. However, non-like things can't dissolve non-like things. So polar solute will not dissolve in a non-polar solvent. Likewise, a non-polar solute will not dissolve in a polar solvent. So sometimes you put stuff in other stuff. Sometimes you put solutes in solvents and they don't dissolve. They don't break apart. They don't disappear. They don't dissolve. They kind of stay there clumped up. And the reason for that is because you're mixing non-polar and polar solvents and solutes. And when that's the case, they won't dissolve in each other. But like dissolves like. So why does Dawn work to remove grease? Well, it all deals with what we just talked about. Dawn, the dish soap, they're always campaigning and saying, hey, we're awesome because we help the wildlife. Anytime there's an oil spill, if you use Dawn, the oil will actually become dissolved in the Dawn, and we'll get rid of that oil from the animals or the oceans and things like that. And the reason for that is because soap, Dawn soap, is a nonpolar compound. And the grease that it's dissolving is also nonpolar. So when the nonpolar solvent when the nonpolar grease is put inside the Dawn, or when Dawn meets up with grease, because they're both nonpolar, they'll be able to dissolve and remove the grease. So that's kind of cool. So solubility changes with temperature. So if you have something that's a higher temperature, the more a solute can be dissolved. So we can actually look at that on a graph here. Excuse me. So we have a graph here of all of these different types of solvents, and these are all polar, by the way, and here we have water. These are all being dissolved in water, and if you actually look at, well, most of these are polar anyways. If you actually look at the compound, each of the compounds, with increasing temperature right here, most of these items up here actually increase their solubility. You can dissolve them more. So a little talking about this graph here, each of these lines represents a different solute that can be dissolved in water. Now, the lines themselves represent the perfect amount of solute that you can dissolve in water. Anything below the line means that it's unsaturated, and anything over the line means that it's too saturated, it's oversaturated, you can't dissolve anymore. Or the lines themselves represents the perfect saturated solution. So here it says how much NaNO3 can be dissolved in water that is at a temperature of 10 degrees Celsius. So what you're going to do is you're going to find 10 degrees. So here's 10 degrees, and you're going to go up to NaNO3. That's right here. So we're right here on this table. And then read off the y-axis. So how much NaNO3 can be dissolved in water? Well, 80 grams of NO3, 80 grams of this salt can be dissolved in water perfectly at the temperature of 10 degrees. So again, let me just remind you what unsaturated versus saturated is. And this is not on your note sheet, but it's useful information right now. So an unsaturated solution, the solvent can hold more solute. So here, if we add it in here, that solute, you can put more solute in, and the solution can actually add more without it actually precipitating at the bottom. So saturated solution, on the other hand, you can't add any more. So if we put 40 grams of sodium chloride in this water, it'll reach a point where it won't dissolve it anymore, and that's called a saturated solution. So again, on the line right here, so sorry, excuse me, going back, on this line right here is saturation. So each of these lines represent the perfect saturation. Anything below the line is unsaturated, and anything over the line means that it won't be able to dissolve it anymore. So think about this in terms of Mountain Dew. If you had 2 bottles of Mountain Dew and you open both, and then quickly put one in the refrigerator and then leave one on the deck during the summer, not right now when it's cold and wintry, but during the summer on a hot summer day, which one's going to lose its fizz faster? Now, this might be something that's happened to you before, and you probably know that the one sitting in the refrigerator will keep its fizz longer, and the one sitting outside will lose its fizz faster. But why is that? Well, the reason is this. In contrast to the solubilities of most solids, the solubilities of gases in liquids decreases with temperature. So we just previously said that if you had a solute, you can dissolve more with increasing temperature. The opposite is true with solvents inside, or gases in liquids. So when we have a gas in a liquid, actually the solution can hold less with increasing temperature. So it means that the hotter it gets, the less gas it can hold, and consequently it can escape into the air. So that's why solutions that are gases that are dissolved inside solutions kind of act the way they do. So here's the solubility of gases, specifically carbon dioxide and oxygen. Notice that these things go opposite of what we saw with the solids in water. So in this case, how many milligrams of carbon dioxide can a 15-degree Celsius container of water hold? Well, same thing. We're going to first find 15 degrees, that's right here, and we're going to go ahead and go up to the CO2 line, that's right here, and we're going to read off the y-axis. So at 15 degrees, carbon dioxide, we can dissolve 20 milligrams of carbon dioxide in water. And this is carbon dioxide gas. So 20 milligrams per 100 grams of carbon dioxide can be dissolved. That's as saturated as it gets. Anything above that is too much and won't work. So if we increase the temperature, we can't get any more than that. However, if we are below that, we can dissolve more, which is great. This is unsaturated, below the line. Well, that is the end of the notes. I hope you guys learned a lot here. Again, you can always rewind the video if you need to and go back and make sure you understand the material. Talk with your instructor if you're struggling, but more importantly, talk with each other, try to teach each other. Good luck, guys. Hope to see you next time.